Historically, catapults were an integral way to siege warfare since before the Middle Ages. The first catapults were attempts to increase the range and power of a crossbow. There are three main types of catapults: the ballista, the mangonel, and the trebuchet. Our catapult resembles the mangonel the most. They were mainly utilized by the Greeks, Romans, and Chinese, and introduced to Europe during the Middle Ages. They would be used to hurl a multitude of objects at the enemy, most often over large, tall, fortified castle and city walls. These objects include, but are not limited to, missiles, stones, sharp wood poles, darts, and diseased bodies. And the first account of biological warfare involves catapults.
For our mangonel catapult model, this type of catapult increases stored energy in the catapult's arm, as well as increases tension in the thick rubber band as the arm is pulled back. The settings changed the resting length of the rubber band, where setting 4's arm was initially closer to the post, decreasing initial tension in the rubber band before the arm is pulled back, as opposed to setting 3. A large amount of the stored energy in the arm goes into swinging the arm, launching the ping pong ball forward. These diagrams show how the catapult looks from a side angle, shown at settings 3 and 4, with the matching force diagrams for the ping pong ball in the catapult at a resting position.
After testing our lovely catapult, we were able to collect some awesome data and make beautiful graphs. However, we found that this data was no longer valid. When we went to test our catapult for our final grade, we discovered that since collecting our data originally, our rubber band had lost its tension, and the catapult was no longer performing to its previous standards. Even after obtaining new rubber bands, our catapult was not the same. But we persevered and retested our catapult, collecting new data for 2 settings to test for our final grade. With our new materials, we were able to collect the new data seen here and make graphs for it. As our 2 newly tested settings reached 1 meter in height, we were able to use those settings during our final test to reach the 1 meter high basket. By using the maximum height of each setting, the distance from the wall of the maximum height, and the initial height of the ping pong ball, we calculated the distance from which we needed to shoot the ball to land it into the basket. And our calculations were accurate. We were able to sink 2 ping pong balls from our calculated distances within 10 trials.
The universe is like, you suffered enough. Take a bow. Thank you.